Hey everyone, Daniel here for Rock the JVM, and this video is about ZIO streams with a realistic example. So we're going to build upon the previous videos in the ZIO streams mini-series, and we're going to go through a larger examples to illustrate the notions that we've learned in the previous couple of videos. So obviously, I'm going to assume that you've watched those two, or that you are already familiar with some essential ZIO streams notions and features. So this will assume that you are comfortable with Scala, that you have some essential ZIO knowledge, which I also teach at Rock the JVM if you're interested in checking that out. I'm also going to leave a link to the course in the description below. And I'm going to recommend that you write code with me to make the best out of this video. And whenever you need to refresh your memory or use the techniques that I'm going to use here, just refer back to the video or to the blog, which contains all the parts in the ZIO mini-series and will contain everything that we've discussed in these videos with detailed explanations. All right, so without further ado, I'm going to navigate back to my development environments, and I have here a ZIO streams example that I've already pre-built, and I'm going to describe what the scenario entails. So I've created this little object, I call this ZIO streams example, and this extends ZIO app default with a simple run method which will run a single effect. We're going to fill that at the very end. And I've imported ZIO, ZIO stream, and ZIO JSON. At the moment of this recording, ZIO is at version 2.0, and ZIO JSON is in development. So you can take the library definitions from the blog post if you're interested in having this in your own dev environment, as well as the code that you see here on screen. This is also available in the blog post. Now, here's what I would like to do in this example. I would like to format a large amount of blog posts written in Markdown for a high volume blog, such as, I don't know, Bildung or dzone or things of that nature. Obviously, I've toned that down to a more manageable problem that we can debug and test live on camera. So we are going to process Markdown formatted blog posts in the form of a pair of file name, which is, for example, helloworld.md, this is the Markdown format, and the content of that blog post, which has a front matter, which is the title and a bunch of tags and a bunch of other information or metadata about the blog post, as well as the blog content, which contains all the Markdown formatting with headers, with links, with hashtags, and so on and so forth. Speaking of hashtags, I would like to do the following. I would like to find all the possible hashtags in these blog posts, and I would like to automatically add them to the tags section in the front matter. So I would like to find everything that's hash with a word in the blog post content, and I would like to add them to the appropriate tags in the appropriate file. So that's objective number one. Automatically find the tags and add them to the tag front matter. The second objective is to be able to format this and change from the tag, as in hash generic, into a link. And the links in Markdown are written in this format. So generic, and then you would have to add a link, for example, /tags/generic or something like that. So I would like to automatically change the generic tag in the form of a hashtag into a link that the users of the blog can automatically search into some search file, which brings me to my third objective. I would like the users to be able to search for a tag. So when they click on a tag, I would like them to search all the files, all the blog posts that have this little tag. So I would like to automatically create a search file with some kind of like a JSON format that will specify for every little tag which files contain that tag. So we would like to process these fictitious files and in the form of a file name and array of byte pairs, and I would like to process them in this style. Automatically add the tags, change the tags to links, and automatically have a search file that will determine for every tag which files contain that tag. Now for this video, I recommend that you know ZIO streams, or rather the essential components at least. So if you haven't watched the previous videos, I recommend that you watch them in the mini-series. Cool. So I'm going to start using ZIO streams to obtain these three objectives. Right, now, because I have a bunch of blog posts that I've manually added here on the screen, I'm going to store them in a map. So I'm going to have, let's call this file map, as a map of string and array of byte. And I've stored them as an array of bytes, given the fact that you might read this content from some sort of input stream, which can give them as an array of bytes or things of that nature. So the rawest form of content. And let's assume you have a map with all these contents. I'm going to have my post 1 associated to post 1 content. Then I'm going to do the same for numbers 2 and 3. So I have post 2 and post 3 with post 2 content and post 3 content respectively. All right. Now, we're going to take things bit by bit. So starting with objective number 1, to automatically add tags to the front matter. First of all, we need to find the tags. So I'm going to create a ZIO pipeline that, given a stream of bytes, we will find the appropriate tags. So I'm going to have, let's call this a hash filter. And this is a function from string to Boolean that I'm going to reuse for the remainder of the application. So I'm going to consider a string that starts with, so I'm going to say starts with a hash, and then the string.count with that hash must be equal to 1. So I'm going to have is equal to 1. String count, I'm going to use underscore must be equal to the hash character. All right, so this must have just one hash because otherwise we're going to get into the headings. All right, and we're also going to consider the length of that string to be at least 2 characters. So the hash and something. So the string.length, so string.length must be greater than 2. I'm going to keep that as the simple filter. Obviously, there are more complicated filters that we can add, but I'm going to keep things super simple. Now, let's assume that I want to parse all these hashes. So considering a string that might arrive at a Z pipeline, I'm going to return another string, which I'm going to return just the strings that match this hash filter. So I'm going to say, let's call this parse hash. This is a Z pipeline. And you probably remember from the previous video, Z pipeline has 4 type arguments. First of all, you have the environment type, which is any in this case, the error type, which is nothing in this case, the input type and the output type. I'm going to keep them as strings. So I'm going to have a Z pipeline dot filter, and I'm going to say underscore, or rather just hash filter. So hash filter. Okay. So I'm going to filter out just those strings which are tags. So hash tags. Now, these strings might have punctuation marks, and they also need to be turned into lowercase because I would like to normalize them. For example, Scala, ZIO, ZStreams, and all that sort. All of them need to be added automatically in tags as lowercase so that we don't have name collisions for different capitalizations. Otherwise, we also need to check whether these so-called words also have punctuation marks such as exclamation marks or full stops. So we need to remove those and keep just the word in the tag. So I'm going to define a regex or regex, if you want to pronounce it that way. I've never known how to pronounce regex, whatever. So I'm going to call this punctuation regex. I'm going to stick to that as a regex. And I'm going to use a triple quote string so that I can use punctuation marks. So I'm going to say I need to import regex first. So Scala util. So I'm going to have my punctuation mark. So I'm going to turn that into a regex. Right. Notice that IntelliJ has automatically detected that this is a regex, so we're going to then use this punctuation regex to replace all the punctuation marks from potential words that we might find. So I've just defined this regex so that I can use it later. Cool. Let me define a Z pipeline that, given these little hashtags, will have their punctuation marks removed. So let's call this remove punctuation as a Z pipeline with, again, any, nothing, string, and string. So this pipeline just processes incoming strings. So I'm going to say Z pipeline.map. And for every string that I receive, I'm going to say punctuation regex dot replace all in the original string, and I'm going to replace them with the empty string, so all punctuation marks removed. Cool. Now, after I've removed their punctuations, I need to turn them into lowercase. So let me define another lowercase as a Z pipeline with any, nothing, string, and string. I'm adding these not necessarily because the type inferrer is bad, but because I want to keep track of my types. And this might or might not be what you want, so you can leave the type inferrer as is. I'm going to use zpipeline map, and I'm going to say underscore to lowercase. And I'm going to chain these Z pipelines together. So considering the contents of a file as an array of byte, I want to turn that into a string. So assuming that I get the array of byte from some kind of input stream or some system that might feed me this content, I would like to turn that into a string. I would like to split by lines, and each line I want to split by words, and every word I want to feed into these pipelines to parse hash, remove punctuations, lowercase, and then just keep the tags. So let me define let's call this collect tags pipeline. This is going to be a Z pipeline. I'm going to leave the type inferrer for now because when I use the decoder from array of byte, this will also give me some sort of exception. I don't remember that off the top of my head. So I'm going to have my Z pipeline and there is a construct called UTF-decode. So notice that ZIO has all sorts of parsing capabilities for bytes and strings. I'm going to use UTF-encode. And then, so I'm going to use this little operator here, which looks pretty nice. I'm going to use a Z pipeline, and then I'm going to split lines. And then I'm going to, for every line, I'm going to split on spaces. So I'm going to have Z pipeline dot split on, and there is this little string, the empty space that I'm going to use. And then considering a pipeline of just words now, I'm going to use parse hash, remove punctuation, and lowercase in that order. So I'm going to say parse hash, so parse hash, and then remove punctuation, and then lowercase. So notice how nice it is to use Z pipelines chained like that because you can embed some really complex computations in just a few lines. So this is pretty powerful in streams libraries in general, in Akka streams, in FS2, in ZIO streams, and so on and so forth. So every one of them has their own ergonomics, and this one is pretty cool as well. All right, so we have this collect tags pipeline. Now, the type inferrer says that this is a Z pipeline of any. Notice that the error type has changed. This is a character coding exception. We get bytes and we return strings. The strings here are just the hashtags, the contents of the hashtag. So Scala, ZIO, ZStreams, implicits, extensions, and generics in this case. Now, given this pipeline, considering the contents of a blog post, let me add the tags and let me add the links. So I'm going to shoot for the first two objectives. All right, now let me define, let's call this add tags. And this is a function. I'm going to define that as a function value because I'm going to pass that along. So I'm going to have, let's say, a set of string, considering the number of the set of all the tags associated to a blog post. So in this case, we have implicits and extensions in a set. I would like to add them to the tags front matter. So set of string to a Z pipeline that is going to take as arguments, we have any, then we have nothing because it cannot fail, string, and string. So considering the blog post content as a string, I'm going to return the new blog post content as a string with the tags inserted. So considering the tags that I might fetch elsewhere, I'm going to return a Z pipeline .map. And considering the contents of the blog post, I'm going to say contents.replace. And I'm going to fetch this little front matter, so tags with the open and closed square brackets. So tags this one with an S-interpolated string where the tags are. And here in this square bracket, I'm going to expand that. And I'm going to have my tags variable, which is a set. So tags, and then I'm going to say make string with a comma. So this is essentially what I'm doing. I'm going to put all the tags here inside the square brackets. All right, cool. So this is the adding of the tags. I also need to add all the links. So I'm going to do that in one go. So I'm going to change the tags to a links in a Z pipeline as well. So I'm going to have my, let's call this add link. Now add link will be a simple Z pipeline. So I'm not considering a set of strings. but I'm rather going to replace the hashtags in place. So as I see hashtags, I'm going to immediately replace them with a link that looks in the style that I showed you earlier. So this is going to be a Z pipeline that will have any and nothing as the first two types. And I'm going to use string and string, and in this case, I'm going to consider parsing just lines instead of the entire blog post. And that is because it's easier to rebuild the line by just adding spaces in between the words rather than replacing the entire blog post. So I'm going to consider a Z pipeline where the strings are lines and the strings are new lines with the appropriate hashtags replaced by links. And by the way, I'm also going to use this add tags here on lines as well because it's easier to replace the lines in the blog post. I'm going to show you what I mean by that. So let me consider the add link as a Z pipeline that parses lines and returns new lines at the blog post. So I'm going to have a Z pipeline dot map, and for every line, I'm going to manually parse that line. So I'm going to say line split on space, and then I'm going to map that line, and for every word that I have inside this line, I'm going to run pretty much the same kind of logic to say if there is a hash filter on this word, so if this word is a hashtag, I'm going to replace that. So I'm going to say if hash filter on the word, then I'm going to return a new string, which is an S-interpolated string, and I'm going to have the regular markdown syntax here. I'm going to inject the word, which is the hashtag itself, and then I'm going to have, let's say, /tags/ and then I'm going to remove all the punctuation marks inside the word. So I'm going to say punctregex dot replace all in word, and I can use word to lowercase. I need to replace that because the link will need to have the word to lowercase. So replace all in word lowercase, and I'm going to return the empty string here. Okay. Otherwise, I'm going to keep the word as is. So else I'm going to return word. So line split map, and now I have an array of words that might have been replaced, and then I need to stitch that line back. So I'm going to have a make string with the empty space. Okay, so the idea here is after I've collected the tags, I would like to take the blog post apart, split it by lines, go through add tags and add link specifically, and then stitch the blog post back together. So let me add a new one to regenerate new lines. So let's call this add new line as a Z pipeline of any, nothing, string, string. And I'm going to have a Z pipeline dot map, and for every line, I'm going to return line plus a carriage return. All right. Now, let me rebuild the blog post. So after I found the tags, I would like to be able to rebuild the blog post. So I'm going to say, let's call this regenerate post pipeline, or regenerate post, exactly as it is. And this is going to be a set of string considering the tags that I've already parsed. And then I'm going to return a Z pipeline of any, and then I'm going to have that character coding exception. Where was that? So we have a character coding exception. That was the type. So this is going to be a character coding exception. This is from Java. And then I'm going to have a byte and byte. So I'm going to get bytes and then return bytes if I want to push that to a regular file. So I read raw bytes, I write raw bytes. So I'm going to have a Z pipeline, and first I need to turn that into a string. So I'm going to have a UTF decode. Then I'm going to split by lines. So I'm going to say Z pipeline dot split lines. And then I'm going to add the tags. So add the tags for every line. So for every line, I'm going to try to replace that. This is a little bit superfluous because only one of the lines will match, but, well, we have the replace that works on all lines as well. So I'm going to have add tags with the tags that I have as an argument. So tags arrow, and I'm going to have add tags with these tags. And then I'm going to add the links. So let's call this add links, plural. So add links. And then I'm going to add new lines. So add new line. And this is going to be a stream of strings, each of which has all the hashtags replaced by links with new lines, and I need to stitch them together, and I need to encode them as with the analogous UTF-8 encode. So I'm going to have a Z pipeline dot UTF-8 encode. So we're decoding, splitting by lines, adding the tags. So replacing the tags front matter with the tag set that I've already acquired somewhere else. Then adding the links, or replacing the hashtags with the links, adding new lines after every line, and then encoding every string as a set of bytes. So I'm pushing bytes one by one or in chunk by chunk. I don't care. This is how the Z pipeline is going to work. Cool. Right. Now, after I've regenerated the blog post, I will want to be able to write that to a file. So I'm going to, let me define a method. Let's call this write file. And let's assume a root directory. So let's call this dir path as a string. And this is going to be, actually, let me add the file name as well. So I'm going to have the file name as a string. And this is going to be a zsync. And as you probably remember from the previous video, zsyncs have 5 type arguments. This is pretty crazy. So we have any, and I'm going to fail with a throwable, just to be a little clear. I'm going to have bytes, so I'm going to consume bytes. I'm going to maybe leftover bytes, but I'm not really sure. I might leave that to nothing. And I'm going to leave long, because long is going to be the number of bytes that I could write. I think this is something that a zsync will be able to tell me after I've written to a file. So I'm going to say zsync, and if I remember correctly, there's a from file name. So from file name returns a zsync with any throwable byte long, which is exactly what I've written here. I think I remember correctly. So from file name with, I'm going to use dir path plus a slash plus the file name. Now, of course, this isn't really portable for Windows. You might want to use the file separator here. Okay, so we have zsync from file name. A zsync from file name consumes bytes and returns a long, which is the number of bytes that were written to the file, and it may leave over some bytes. All right. If for some reason that output stream failed to write to the file, you get some bytes that were not written to the file. For some reason, we won't really care about them. Everything is going to work exactly smoothly. Okay, anyway. So we know how to write to a file. Cool. Now, I'm also going to write a sync that after I've collected the tags in the pipeline, I'm going to return that or retrieve them to a set in order to feed them later to the other regenerate post pipeline, which considers the set of tags that I have acquired elsewhere. So I'm going to write the syncs here as well. So let's call this, actually define that as a val, so call this collect tags. And this is a zsync, and I'm going to consider any and nothing. I won't fail, of course. I'm going to consume strings. I will leave over nothing, and I'm going to return a set of string, which is the set of all the tags that I'm interested in. All right, so I'm going to have zsync, and there's a transformer here called collect all to set. So collect all to set will simply fetch all these strings that I receive here in the sync and push them all as a set of string until the stream has finished. So I'm going to acquire strings, and when the stream finishes, I'm going to return the set of all strings that arrived here. So collect all to set. Okay, now, so I've added, for the first 2 objectives, for adding tags and changing tags to links, I have a bunch of pipelines. Let me separate them a little bit. So let's call this objective 1 for finding or replacing tags in front matter. And we have hash filter, parse hash, punctuation regex, sorry, I missed my pronunciation, and I have my collect tags pipeline. I also need my collect tags sync, so I'm going to take that out and put it here. Right, now, the adding of the tags is a Z pipeline that rebuilds the blog post. Cool. And for objective number 2, so this is objective 2, which replaces tags with links. So we have add links, add new line, regenerate post. So this is objective 1 plus objective 2. So after I've regenerated the blog post, I'm going to write to a file. Now, I'm going to define a function. Let's call this auto tag. And I'm going to have my file name as a string, and then my contents as an array of bytes, because that's how I stored them earlier at the beginning of the example. And I'm going to return a ZIO effect. So I'm going to run a for comprehension. Cool. So let me run a for comprehension. So I'm going to have my tags, which are fetched from my first Z stream. So I'm going to have Z stream dot from iterable, and I'm going to consider the contents as my bytes that I'm going to feed into the source. And then I'm going to say via this collect tag pipeline, so to collect tags pipeline that I've defined earlier. So UTF encode, split line, split on space, parse each word, remove punctuation, and then lowercase, so this will return just the hashtags. So this is going to be a hashtags, and then I'm going to have, I'm going to run with the sync, which is called collect tags. So I'm going to collect them all as a set. First of all, I'm filtering them out as just the hashtags, and then I'm going to say collect all. So collect tags. And I'm going to yield unit first because I want some type inference here. So tags is now a ZIO with set of strings. So tags, the tags variable is just a set of strings. Then I want to debug something. So I'm going to use console.println with, let's say, generating file, and I'm going to inject the file name. Okay. And then I'm going to run the first I'm actually going to run this regenerate post thing. So I'm going to run an effect that says zstream.from iterable, and considering the contents. I'm doing 2 passes of the file over the file, which is a little bit suboptimal. But first of all, you need to parse all the entire file, and then you need to go through it again to replace all the tags. So I don't know if there's any nicer way to do that. There may be some nicer ways. If you have them, I'm waiting for them in the comments. So via, and I'm going to use regenerate post, and then I'm going to run with the write file method. So I'm going to say write file at a directory, and here I have source main resources. I prepared a little data folder, so I'm going to have source main resources data, and I have ZIO-streams. And the file name, and the regenerate post here is a function, so I'm going to need to pass the tags here. Okay, and run with write file at this file name, and I'm going to yield, I'm not going to yield unit actually, I'm going to yield the tags associated to this file name, because this will be useful for me later when I want to create this index file. So I'm going to yield the tuple of file name and tags. Okay, so this is a sequence of ZIO effects. Each ZIO effect is built out of a stream itself, so that's nothing to worry about. And after I've finished, I'm going to return a tuple, that is a ZIO of a tuple, and I'm going to return the tuple, the association between the file name and the set of the tags in that file. Cool. Alright, now I need to parse all the files, so given the fact that I have a file map, I'm going to process them at the same time. So I'm going to define an effect that goes through all the files and calls this little method for every one of them. So I'm going to call this auto tag all, and I'm going to use ZIO for each. And ZIO for each has a bunch of overloads. I'm interested in something that treats a map. Where was that? I think there was... So I'm going to say ZIO for each on file map. I think there is an overload for that. So if I command click on this one, it gives me a for each that iterates over a map. and returns a ZIO, and the desired value is another map, which is great. So I'm going to iterate over the file map, and I'm going to turn this file map, the map of the association between the file name and the content, into a map of file name to hashtags contained in that file. So I'm going to say ZIO for each file map. I'm going to have a case for file name and contents, and I'm going to run this little auto tag thing. So I'm going to say auto tag with the file name and the contents, and this returns another ZIO with the file name and tags. So this is going to be a ZIO which has a map of string to set of string. So this effect will go through all the files, and at the end of the day, I'm going to return a map where for every file name, I'm going to have a set with all the hashtags in that file, which is absolutely brilliant. Now, considering that map with all the tags in every file, I would like to do the reverse association. So right now I have a map for a file name to all tags in that file, and I would like to return a map for every tag. I would like all files with that tag. So kind of like a reverse association. So I'm going to define, let's call this create tag index. That has a tag map as a map of string and set of string. I think the blog post has a slightly different approach to this, but the code is essentially equivalent. So I'm going to have let's call this val search map. So search map, and I'm going to have my tag map, and I'm going to process that. So tag map, I would like to fetch all the unique tags in all the files. So I'm going to have tag map values, and then I'm going to say to set. So I'm going to have a set of sets. So set string. I would like to collapse that, so I'm going to have flatten. And then, so this is going to be just a set of string, which is the set of all the tags in all the files. And then I would like to map each one. So map, and for every tag, I'm going to associate that tag to all the files that contain that tag. Now, all the files are all the keys in tag map. So I'm going to have tag map filter, and I'm going to say for every pair, I'm going to say that for every pair, the second member, which is the set of all tags in the file, contains this particular tag. So I'm going to say contains tag. And then I'm going to return just the keys of this map that I'm going to obtain. So tag map filter __ to contains tag will give me back a map with the association between which contain just the associations between those files that contain this particular tag, because I've added a filter here. Now, I only care about the file names, which is why I've added the keys modifier here. And then I'm going to return that to a set as well. So I'm going to return just the file names. Okay. And then I'm going to return to map. So I'm going to have a set of tuples between string and set of string. So for every hashtag, I will return a set of all the files that contain that tag, and then I'm going to return a map. Okay, so I hope that makes sense. It was quite a lot of modifiers along the way. And then I'm going to go zstream. So I'm going to say zstream dot from iterable. And I would like to turn this search map into a JSON, which is why I've added the ZIO JSON library. So zstream dot from iterable, I'm going to say search map dot to JSON pretty. Okay, so to JSON pretty, this returns a string. I would like to turn that into bytes. So get bytes, because I would like to write that to a file. So I'm going to say dot run with a zsync, I think. Zsync from file name, and I'm going to use my previous path. So source main resources data, ZIO streams. Let's call this search.json. All right, so I'm turning this map into a JSON string, obtaining the bytes, and pushing them to a file. Okay, so this create tag index returns a ZIO that returns the number of bytes that were written to the file. I don't care about the bytes written, I only care that the file is written. So I need to combine all these together. So this is for the objective number 3. So this, let me add objective 3, add the search index file. And I'm going to put that at the top because these maps are my internal representation of what I want. Okay. Fine, now let me combine everything that I've written so far into a giant program. So let's call this parse program, or parse entire blog post or something like that. And I'm going to run a for comprehension, and I'm going to call auto tag all. So for all the files, I'm going to return all the hashtags plus replace all the tags. So I'm going to say tag map in the auto tag all effect. And I'm going to print something to the console to say the fact that I'm generating the search file. So I'm going to say console print line with, let's say, generating index file, search.json. And then I'm going to run this little function, the create tag index, on the tag map that I obtained earlier from the previous effect. So I'm going to say create tag index file. I should name this to create tag index file, whatever. The tag map, and I'm going to yield unit. So yield unit, I don't care about the return value. And this parse program will be essentially my run method. I've written a lot of code. This can crash in any place now. So let me do a roundup of what we've done so far. So for objective number 1, we've added a bunch of filters here so that we can parse the blog post by lines and then by words. And the words themselves must have hash and so on and so forth described by the hash filter. So the collect tags pipeline is a Z pipeline that, given a blog post, I'm going to collect all the tags as a set. And the set here is for the, where was that? We have collect tags, which was right below it. I organized it myself. So this little stream, which has the source, the pipeline, and the sink, will give me back a set of strings, which are all the hashable or the hash tags in the file. Okay. Now the add tags is a pipeline that will replace all the tags here in the front matter of the blog post. That was objective number 1. For objective number 2, we added another Z pipeline that processes every line independently and replaces every hash word with a link. And I added this as a new pipeline. So I have, with regenerate blog post, I'm going to have to add the tags, add the links so that I replace the blog post in one go, and add new lines for every line, and then push all the lines as bytes to a file, which is why I wrote this little method to write the file at a directory path under a file name. So I'm pushing all the bytes at this path. Good. Now, finally, for objective number 3, I added this little function to automatically tag a file name with the contents. So I wrote all these, I put all these components together as ZIO streams and turning them into ZIO effects. So collecting the tags, pushing the tags to the files, and then write them to the file as specified earlier. So this auto tag connects all the components together and returns tuples of file name and tag so that I can use them later in my search file. All right, this auto tag all effect does the same thing for all the files in my sequence. So in the file map, I'm going to simply call the auto tag method for each. And for the objective number 3 for the search index, I'm simply considering the tag map which I've obtained earlier, processing them with functional programming primitives. I explained what they do, and running the Z stream as from iterable with the search map to JSON pretty get bytes to be able to turn this map into a JSON string and pushing that to a single file. And the final giant program will simply connect all these together as independent effects. And I'm running this at the very end. This is probably going to be a journey. All right, so I've talked a lot and I wrote a lot of code. Let's see if this works. I'm expecting this to crash any minute now. But surprisingly, my output worked correctly, and my ZIO streams didn't fail. All right, let's see what we got. I would be surprised. So we have data ZIO streams, and we have Hello World MD, Scala 3 extensions MD, ZIO streams MD. These are the files with the appropriate file names. Let's check Hello World. So we have tags automatically added here for generic, so this is great. We have the hashtag generic and with the link, which is great. So we have the hashtag here in the link. We can click that if this was a real blog post. Let's check this one. This one had multiple tags, and notice that we added them here in the tags front matter, and all the links are properly added. There's one caveat here with the extensions with a dot at the end. This is also included in the link, but finding all the punctuations and adding them outside the link would probably be a little tedious, so I'm quite happy with that. And the ZIO streams thing, we had some tags with some capital letters, so we had ZIO, Z streams, and Scala, and also with some punctuation marks. These are also added correctly, so this is great. This is good. So the first two objectives are successfully completed. Now I think Scala 3 extensions and ZIO streams have the same hashtag Scala, and I'm expecting this hashtag Scala to be associated with both of these files, ZIO streams and Scala 3 extensions. So let's look at the search JSON. So notice that this JSON string has automatically been formatted, which is great, because we had the ZIO JSON library. Let me uncollapse that and let's see what we have. So Z streams are in ZIO streams. Implicits are under Scala 3 extensions MD. Generic is under Hello World MD. This is great. Extensions is here as well. ZIO is in ZIO streams, and the hashtag Scala, which occurred in two files, is correctly associated with both of these files. So objective number 3 is also correctly completed. All right, folks, so this was a whirlwind, but this showed you a realistic example of what you can do with ZIO streams. I hope you enjoyed it, in which case I recommend that you like this video and subscribe to the Rock the JVM channel for more videos like this. Check out the ZIO course that I've just launched. It contains everything in the core ZIO library and the ZIO effects, so check that out. Also, check me out on Twitter and LinkedIn. I post fresh updates on upcoming material, and check out the Rock the JVM website for everything in the Scala ecosystem. I have literally hundreds of hours there. So until the next time, I'm Daniel, signing off.